Hi, greetings everyone. I'm Asif Azad. Today we are presenting design and test a monitoring SCADA system for a hybrid power plant. Table of contents. So this will be our table of contents. This will be where we will be covering in this presentation. Objective. This is a design and a test a SCADA monitoring system for a hybrid system that was designed in 1998 in McCallum and Newfoundland, Canada. We use Arduino Uno for the microcontroller and the MS Excel for the data streamer. This monitoring system allows the operator to take necessary steps to maintain the continuous supply. By SCADA system, it will be able to monitor the total power, the voltage current, and the generation power. Implementing a SCADA system it can be a little tricky for a hybrid power plant as it's a big and it's also a risky, and the plant is also situated in a floating situation. Project breakdown: over 280 communities in Canada with approximately 200,000 people are disconnected from North American electric power system. McCallum, Newfoundland, Canada is a remote community and needs a sustainable, reliable solution for the betterment of the community. People are using diesel fuel and it's not very cost effective. This approach presents in the study is super cheap and for the real-time monitoring. The design was built on Arduino board and in Excel data streamer using voltage and current sensors. Problem statements. Various things can go wrong while this project. Sensor can be damaged while connecting the sensors. Loose connections, fault words can also be found during the setup. The setup was done on Arduino, and getting data from the Excel can be tricky while connecting the Arduino and the Microsoft Excel. The coding is also can be a big factor here. It can end up in the fault coding. So if fault coding means wrong results. A prepared controller is must for the individual identifying the panel. So quick fix can be easier for the operator. For the quick fix, we have to do the individual identifying for each panels here.
Hi, this is Mrinmoy Kundu. In this slide, I am going to explain our strategies to develop a monitoring system for our proposed hybrid power plant. In this diagram, we can see a basic design of the power plant, where on the left we can find the hybrid generation site and the load site area in the middle, including power storage and transmission section. We have to collect the data of generated voltage and current to monitor the total generated power from this system. For developing our monitoring system prototype on a small scale, we are using Arduino UNO to collect the generation data and transfer it to the system. We are using voltage and current sensor to sense the generated voltage and current. And finally, we are using Excel data streamer to collect the sample data from Arduino and prepare a graphical representation of our generated voltage, current, and total power. Let's talk about the equipment that we are using. At first, Arduino UNO. This is an open source microcontroller board based on the microchip Atmega 328P microcontroller. The board has total 14 digital input-output pins and 6 analog input pins. It can be powered by a USB cable or a barrel connector that accepts the voltage between 7 and 20 volts. Its main microcontroller Atmega 328P, which has a clock speed of 16 MHz and capable of 20 MHz maximum at 5 volts. With a flash memory of 32 KB, it is equipped with 2 KB SRAM. This board needs to be connected to a computer with a USB-B connector. Arduino board is needed to be programmed to perform different operations. We are using Arduino IDE to program our UNO board to collect data from sensors and send them to our system. Next, we are using a voltage sensor to collect total generated voltage data from source. This sensor is capable of sensing 25 volts maximum. There are three male header pins denoted by S positive and negative get connected with the Arduino board, and two-pin screw terminals ground and VCC need to be connected with the source. We are also using a current sensor to sense the total current supply to the distribution part. This sensor is known as AC712, which contains inbuilt Hall effect device. The Hall effect sensor detects the magnetic field when some current passes through this copper conductor. Our AC712 voltage sensor has three male header pins, VCC out and ground, and two-pin screw terminals, current in and current out, stays connected with the phase of source and load, respectively. Data Streamer is an essential tool of Microsoft Excel for two-way data transfer. It collects data from sources and stores in Excel datasheet form. Along with the Arduino IDE, we have used this tool to collect real-time data from Arduino processor and present a graphical overview of total generated voltage, current, and power. At first, we started developing the prototype in our lab by measuring the voltage and current individually using sensors. To measure the voltage of the source, we took the voltage sensor and connected it with the system and Arduino UNO. We have connected the sensor following this diagram. Here, the S pin is connected with the A0 port, and the negative pin is connected with the ground pin of the Arduino UNO. On the other side, we have two connection terminals, VCC and ground, which are connected with the positive side and the ground of the voltage source respectively. For this prototype, we are maintaining 5 volts from the source. Here is the prototype we have developed to measure voltage. We have used Arduino IDE to program the board. Then in the IDE interface, we got the source voltage as 4.96 volt. We have also imported this data to Excel using Data Streamer add-on, where you can see real-time data logging with timestamp. In the same way, we developed a prototype using current sensor. We have connected our ACS712 current sensor with the source and the load as well as with Arduino UNO. Following this diagram, we have connected VCC pin with 5 volt, out pin with A0 and ground pin with ground port of the Arduino UNO. On the other side, two connection terminals, IP positive and IP negative, which are connected with the two phase terminals of the source and the load side. We have considered a 10 ohm resistor as load. Both grounds of the source and the load are interconnected. Here is the prototype we have designed at our lab. After programming the Arduino with the source code, we are getting the output voltage as 5.12 volt, whereas the current is 0.63 amps. Like as the voltage sensor data log, we have collected the data from the current sensor. Here we can see the Excel data streamer collecting the sensed data from the Arduino UNO and logging in the Excel sheet with timestamp.
Hello, this is Chowdhury Abdullah Mahbub. I'm starting my presentation by presenting our final design. As we already have designed two individual prototypes to test our current and voltage sensors and to get assured that they are working fine. Now it's time to get done our final design. For doing it, firstly, we modified the microcontroller program using IDE software and made a combined program for both voltage and current sensors. As Arduino Uno has multiple analog inputs, so we use two of those for getting voltage and current input simultaneously. Analog input pin A0 used to get voltage reference from the voltage sensor, and analog input A1 has been used to receive the current reference from the current sensor. Both these pins are defined in our program. This is the final block diagram of our designed system. Left side of this diagram shows the proposed hybrid power system for which we are designing this SCADA system. It contains PV module, battery storage, and diesel generators. The PV modules and battery banks are connected to the DC bus, and a DC to AC converter is used to get AC power. Finally, a transformer is used to get desired voltage level, then connected to the AC bus, and the diesel generator is directly connected to the AC bus. Now, to measure the voltage and current, we made the circuit arrangement like the right side of this figure. The VCC and ground pin of voltage sensor are connected to the phase and neutral of the generating source. The output pin S and minus are connected to the analog input pin A0 and ground pin of the microcontroller respectively. For current sensor, input pin is connected to the phase of the source and other input pin is connected to a load. We used a variable resistance as a load, and the other end of this resistor is connected to source neutral. However, the output pins of current sensors, which are VCC, out, and ground, are connected to 5-volt analog input A1 and ground of the microcontroller. Finally, we connect the Arduino Uno with Microsoft Excel data streamer through communication port of monitoring computer. Then we made our final prototype for this project. These figures shows the final prototype that we designed at lab. We made the proper connections and then uploaded the program to the Arduino. The figure 1 shows sensors connection with Arduino, figure 2 shows power supply, and finally figure 3 shows Arduino connection with Excel data streamer. After testing the final prototype, we were able to measure the supplied voltage and current drawn by the load resistor. The measured value was approximately same as the supply, as like we got voltage more than 4.91 volt where supply was 5 volt. Power has been calculated using the basic power equation. Although we use DC supply in lab, the three-phase AC power equation is used to calculate the power considering our main power station. The figure presented here shows the measured voltage, current, and overall power, as well as a graphical representation of our measured parameters have been shown. We got all straight lines for all parameters because the load was fixed. We also varied the load by varying the resistance to check the system responses. Then we got variable current as expected. Therefore, the power also fluctuated with the current. We can see from this figure that any changes in the inputs makes an instant changes in the outputs, and the graph also shows these variations. Consequently, the system is working precisely and monitoring the live voltage, current, and power of the system. Here we concluding our presentation. However, a SCADA system is essential for a hybrid power plant because it provides a centralized control and monitoring system for its various components, allowing the efficient and effective power generation process management. So our project aim was to design and test a monitoring and SCADA system for a hybrid power plant that we have done successfully. This system allows continuous monitoring the essential basic generation parameters. Besides, this is a very cost-effective and easy to install system that would require minimum maintenance. It will help to reduce the human interaction since it takes less time and money, and also helps to prevent the inaccuracies that come with multimeter readings. With the suggested solution, data will be monitored and recorded more quickly. Analyzing such data will enhance the functionality and performance of the hybrid power system. Here are the references which are very helpful during our project work. This is the end of our presentation. Thank you so much.